Hello, in this lecture we'll find out the length of line segment QB that is equal to x. The drawing, we have a semicircle. This is called AP, that is equal to 10 units in its length. This is called PQ, that is also equal to 10 units in its length. This is line segment QB, or chord QB, that is equal to x. And our mission is to find out the value of x, or the length of line segment QB. In addition, you know that AB equals to 30 units in its length. Actually, AB is the diameter of this circle, that is equal to 30 units. So, first of all, we define the center of this semicircle, this point is point O. And we know that the diameter of this semicircle is 30, therefore the radius must be equal to half of it. That is to say, the radius must be equal to 30 over 2, that is 15. AO is the radius of this semicircle, that is 15. OB is also the radius of this semicircle, that is equal to 13. In the next step, we will complete the semicircle to a circle. And we join points P and O together by straight line. Point O is the center of this circle or semicircle. Point P is the point of the circle itself, therefore PO is the radius of this circle, that is equal to 15 units in its length. In the next step, we will extend the radius PQ until it touches the circle. And we define the touching point of the extended radius PQ with this circle. This point is point M. In the next step, we join points B and M together by a straight line. Those two angles, they are defined as vertex angles, and we have the rule that vertex angles are equal to each other. So if we define this vertex angle as theta, then this vertex angle also must be equal to theta because they are equal to each other. Okay. So in the next step, we'll prove that triangle APO can go into this triangle MBO. Actually, OM is also the radius of this circle, that is equal to 15 units in its length. So we prove that those two triangles can go into each other. So this is triangle APO. And this is triangle OBM. So why those two triangles can go into each other? First of all, OP equals to OM. They are both the radii of the circle, therefore they are equal to each other. So write it down. Side OP of triangle APO is equal to side OM for triangle OBM. The above the radius of the circle is equal to 15 units in its length. Therefore, they are equal to each other. In addition, those are two vertex angles that are equal to each other. So this is angle AOP. And it is equal to this angle. This is actually angle MOB. So angle AOP, the right triangle APO, equals to angle MOB, the right triangle OBM. They are both equal to each other, therefore they are equal to each other. Actually, they are equal to each other according to the rule that vertex angles are equal to each other. And finally, side AO is equal to side OB. They are both the radius of the circle, therefore they are equal to each other. So side AO of the right triangle APO is equal to side OB of the right triangle. It is not the right triangle, it's triangle OBM. They are both the radius of the circle, that is equal to 15 units in its length, therefore they are equal to each other. So we found out that triangle APO congruent, this is the sign of congruent, to triangle OBM according to side angle side rule. Actually we have here those two sides and the angle that is included between those two sides in triangle APO are correspondingly equal to those two sides and the angle that is included between those two sides, that is angle theta, in triangle OBM. And therefore those two triangles can go into each other according to side angle side rule. We have two sides and angle that is included between those two sides that are correspondingly equal to those two sides and the angle that is included between those two sides in triangle MOB. Therefore, those two triangles, the all triangles, those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we derive that side AP in the right triangle, side AP in triangle APM is equal to side MB in triangle OMB. So write it down. AP equals to MB. AP equals to MB according to the rule that corresponding sides and congruent triangles are equal to each other. Those triangles can go into each other, and therefore the two corresponding sides, that is to say side AP and side MB, must be also equal to each other. But AP is 10 according to what is given us in the question. So we can write here that AP equals to 10. And from this equation, 10 equals to AP equals to MB, we will derive that side MB is also equal to 10 units in its length. MB equals to 10 units. Chord PM, this is chord PM, passes through point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter. Therefore, PM is the diameter of this circle or semicircle. So I'll copy the semicircle, this semicircle, with the diameter PM, and we analyze the semicircle with diameter PM. So 3, this is the semicircle with diameter PM. PQ equals to 10 units in its length, NB also equals to 10 units, and QB equals to X. X is the line segment that we are looking for in this question. So the next step, we'll extend side PQ and side NB until they intersect with each other. So, okay, this is their intersection point. This is the intersection point of the extended side PQ and the extended side MB. So when you find this intersection point, this point is point E. By doing this construction, we're going to do triangle PEM. This is triangle PEM that we created by extended side PQ and side MB. This triangle PEM, line segment PQ equals to line segment MB, it is equals to 10 units. So we extended the two equal sides by a straight line until they intersect at point E. So those two sides must be also equal to each other, and therefore in total, so if we define this length of side QE as Y, then the length of side BE must be also equal to Y because they are equal to each other. So in total 10 plus Y equals to 10 plus Y. Therefore side PE is equal to side ME. Each side is equal to 10 plus Y, and therefore those two sides PE and EM are equal to each other. So in triangle PEM, we actually found out that side EP is equal to side EM. Okay, again, in this triangle EPM, side EP equals to side EM. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of this side EM, we have this angle. In front of this side EP, we have this angle. And because of the fact that those two angles are located in front of those two equal sides EP and EM, they must be also equal to each other in their sizes. So if we define the size of this angle as beta, then the size of this angle must be also equal to beta, because they are equal to each other according to the rule that I mentioned. So we have here, this is quadrilateral PQBM that is inscribed by this semicircle. If we complete the semicircle to a circle, this quadrilateral will be inscribed by a circle. So I can say that quadrilateral PQBM is inscribed by a circle, and we know that any quadrilateral that is inscribed by a circle, the sum of its two opposite angles must be equal to 180 degrees. So those are two opposite angles of quadrilateral PQBM, and the sum of those two angles, they must be equal to 180 degrees. So angle beta plus this missing angle, in total the sum of those two angles must be equal to 180 degrees, because of the fact that this quadrilateral PQBM is described by a circle. So this missing angle must be equal to 180 degrees minus beta. Why? Because 180 degrees minus beta plus beta is 180 degrees, exactly according to the rule that the sum of the angles in a quadrilateral that is described by a circle is equal to 180 degrees. So 180 degrees minus beta plus beta is 180 degrees, and it is exactly according to the rule that I mentioned. Likewise, those two opposite angles inside quadrilateral PQBM in total must be equal to 180 degrees. Therefore, this This angle must be equal to 180 degrees minus beta. So actually, those two angles, they are defined as one-sided interangles. And we have here, and the sum of those two angles is 180 degrees minus beta plus beta is 180 degrees. So the sum of those two one-sided interangles is equal to 180 degrees. And we have here rule 18 that we can implement here. According to rule 18, if the sum of two one-sided interangles is equal to 180 degrees, then they are located between two parallel lines. So the moment we have line A and line B, this is the red line C that intersects with those two lines at those 2 points, and we have also those two angles alpha and beta that are defined as one-sided interangles. And we know that alpha plus beta is equal to 180 degrees. Again, we know that angle alpha plus beta is equal to 180 degrees. And therefore, because of the fact that alpha plus beta is equal to 180 degrees, we conclude that line A is parallel to line B. Again, because of the fact that alpha plus beta, that are two one-sided interangles, the sum of those two angles is equal to 180 degrees. Therefore, line A must be parallel to line B. So I can actually implement rule 18 in our drawing. Why? Because in our drawing we have those two one-sided interangles, and the sum of those two one-sided interangles is equal to 180 degrees. Why? Because 180 degrees minus beta plus beta is 180 degrees. So we know that the sum of those two one-sided interangles is equal to 180 degrees. Therefore, according to rule 18, they must be located between parallel lines. That is to say, and they are located between line QB and line PM. And therefore, according to rule 18, line QB must be parallel to line PM. Again, according to rule 18, line QB must be parallel to line PM. So I'll write it down. According to rule 18, because of the fact that those are two one-sided interangles, and we know that the sum of those two one-sided interangles is equal to 180 degrees, therefore they must be located between two parallel lines, and they are located between line QB and line PM, and therefore line QB must be parallel to line PM. According to rule 18, line QB must be parallel to line PM. See it again. Line QB must be parallel to line PM. Okay. So if you found out that line QB is parallel to line PM, so line QB is parallel to line PM. Line QB is parallel to line PM. Again, those two lines are parallel to each other. Line QB is parallel to line PM. So I'll copy the semicircle, this semicircle again, and we'll continue to analyze this semicircle. So I can find out that line QB is parallel to line PM. So here, this is the semicircle with the diameter PM that the coming from the original drawing. Side PQ equals to 10 units in its length, QB equals to X. X is the line segment that we are looking for in this question. And BM equals to 10 units in its length. In the next step, so we know that point O is the center of the semicircle, point P is the point of the semicircle itself, therefore OP is the radius of this semicircle, that is equal to 15 units. OM is also the radius of this semicircle, that is equal to 15 units in its length. So in the next step, we join points O and Q together by a straight line. Again, point O is the center of this semicircle, point Q is the point of the semicircle itself, therefore OQ is the radius of the semicircle, that is equal to 15 units in its length. And finally, we join points O and B together by a straight line. Point O is the center of this semicircle, point B is the point of the semicircle itself, therefore OB is also the radius of this semicircle, that is equal to 15 units in its length. As I already mentioned before, according to rule 18, line QB, this is line QB, is parallel to this line PM. Line QB is parallel to line PM. And because of the fact that those two angles are located between the parallel lines QB and PM, and they are defined as alternating angles. And according to rule 15, alternating angles between parallel lines are equal to each other. So in the moment we have line A that is parallel to line B. Those two angles, alpha and beta, they are defined as alternating angles. And because of the fact that those two alternating angles, alpha and beta, they are located between the parallel lines A and B, they must be equal to each other. That is to say, angle alpha equals to angle beta. So we can implement rule 15 in our drawing. Why? Because of the fact that those two angles are defined as alternating angles, and they are located between the two parallel lines QB and PM. Again, QB is parallel to PM according to rule 18. QB is parallel to PM, and those two angles are located between the parallel lines QB and PM, and therefore they must be equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha, because they are equal to each other according to rule 15. Okay, so in the next step, I present to you the law of cosines. I'll repeat on the law of cosines, and we'll implement the law of cosines in this triangle OQP, and in this triangle OQB. So, repeat quickly on the law of cosines. The law of cosines is true in any triangle. So actually, this is triangle ABC, that could be any triangle. This is angle theta. And we know that the length of side AB is equal to A units in its length. Side AC equals to B units in its length. This is side BC, that is equal to C units in its length. So in this triangle ABC, cosine theta equals to a squared plus b squared minus c squared divided by 2 times a times b. I repeat again. In this triangle ABC, that could be any triangle, cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. So the next step, I'm copy this triangle POQ in a new page and we will implement the law of cosines in this triangle POQ. As I already mentioned before, the law of cosines is true in any triangle. Angle OQB equals to alpha and QB, side QB equals to X. X is the line segment that we are looking for in this question. Actually, I'll copy triangle PQO. This is triangle PQO. So we have here side OQ equals to 15 units in its length. Side PO is also equals to 15 units in its length. And PQ equals to 10 units in its length. And this is angle alpha. So I copy again the triangle. Now talking about the green triangle, triangle PQO. So really, this is the green triangle PQO that I copied from the original drawing. This triangle PQO, according to the law of cosines, cosine alpha, this is angle alpha, cosine alpha, this will be equation 1, cosine alpha equals to 15 squared plus 15 squared minus 10 squared divided by 15 by 2 times 15 times 15. Exactly according to the law of cosines. Cosine theta equals to a squared plus b squared minus c squared or 2 times a times b. So implementing the law of cosines in this triangle PQO. In the next step, I'll copy this triangle OQB in the new page, and we'll implement the law of cosines on this white triangle OQB. QB equals to x is the line segment that we're looking for in this question. This is angle alpha. Side QO equals to 15 units in its length. And side OB also equals to 15 units in its length. So actually, this is the white triangle OQB that I'm going from the original drawing. In this triangle OQB, according to the law of cosines, this will be question 2, cosine alpha, this is again alpha, cosine alpha equals to 15 square plus x square minus 15 square divided by 2 times 15 times x. Okay, this equation is the implementation of the law of cosines in this triangle OQB. Only to this equation 2, cosine alpha equals to 15 square plus x square minus 15 square over 2 times 15 times x. So we have two different equations for cosine alpha. In the next step, we create equation 3. Let's say that cosine alpha according to equation 1 must be equal to cosine alpha according to equation 2. So cosine alpha according to equation 1, this is equation 1, cosine alpha according to equation 1 is equal to 15 square plus 15 square minus 10 square divided by 2 times 15 times 15. So this is cosine alpha according to equation 2. So cosine alpha according to equation, actually this is cosine alpha according to equation 1. This is equation 1. So cosine alpha according to equation 1 must be equal to cosine alpha according to equation 2. This is equation 2. So cosine alpha according to equation 2 is equal to 15 square plus x square minus 15 square divided by 2 times 15 times x. Repeat again, equation 3 means that this is cosine alpha according to equation 1 and it must be equal to cosine alpha according to equation 2. So here we have 2 on both sides of the denominator of this expression, so 2 will get cancelled, and we also 15 on both sides of the denominator of this expression, so 15 also will get cancelled. And here we have 15 square minus 15 square is 0, so that will be cancelled. So in this side of equation 3 we left only if x square over x, x square over x is of course x, and it is equal to, here we left with 15 square plus 15 square minus 10 square divided by 15. So in total, according to equation 3, we found out that x equals to 15 square plus 15 square minus 10 square over 15. So actually x equals to 15 square is 225. So 225 plus 225 is 450 minus 10 square, that is 100, so it is minus 100 divided by 15. So we found out that x, according to equation 3, x equals to 450 minus 100 is 350 over 15. Here we divide both the numerator and the denominator of this expression by 5, and you get that, according to equation 3, x equals to 350 over 5 is 70, and 15 over 5 is 3. So in total, x equals to 70 over 3, that is actually 23 and third units. So actually we found out that that is the answer to the question. We actually found out that the length of this standard cubit is equal to x. It is equal to either 70 over 3 units, or in terms of numbers, the length of this standard cubit that is equal to x is equal to 23 and third units. So finished to answer on the question. So in the next step, I'll summarize the lecture. So in this lecture, our mission was to find out the length of this 9/7 cubit is equal to x. We have to find out the value of x. So in the drawing, actually in the original drawing, we had this semicircle. Inside this semicircle, we have port PQ that is equal to 10 units in itself. This is port AP that is equal to 10 units in itself. This is port PQ that is also equal to 10 units in itself. AB, that is the diameter of this semicircle, is equal to 30 units in itself. And this is line segment QB. The length of line segment QB is x. And our mission to find out is to find out what is the length of QB that is equal to x. So we have to find out the value of x. So first of all, because of the fact that the diameter of this semicircle is 30, therefore the radius must be equal to half of it. The radius must be equal to 30 over 2, that is 15. So the radius OA is 15, the radius OB is also 15. We define actually the radius, the center of this circle is point O. So OA is the radius that is 15, OB is also the radius that is 15. And actually we completed this semicircle to a circle, and we join points P and Q together by straight line. P and O together by straight line. PO is the radius of this circle that is equal to 15. We extended the radius PO until it touches the circle, and we find the touching point of the extended radius PO with this circle. This point is point M. The next step we join points B and M together by a straight line. And those two angles, they are defined as vertex angles, and we know that vertex angles are equal to each other. So this angle instead are the this angle must be also equal to each other because they must be equal to each other. So in the next step we prove that this triangle PQA can go into this triangle, triangle QBM. So why those two triangles can go into each other? First of all, PO equals to OM, they are both the radius of the circle, therefore they are equal to each other. In addition, those two angles are defined as vertex angles, and vertex angles are equal to each other. And finally, side AO equals to side OB, they are both the radius of the circle, therefore they are equal to each other. So if we prove that those two triangles, triangle PAO and triangle OBM, they can go into each other according to side angle side rule. We have those two sides and the angle that included between those two sides are correspondingly equal to those in triangle PAO are correspondingly equal to those two sides and the angle that included between those two sides in triangle MOB. Therefore those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will derive that PA is equal to BM. PA equals to BM according to the rule that corresponding sides of congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides PA and BM must be also equal to each other. Okay, so AP equals to BM or MB. But it is given as a question that AP equals to 10 units. So we can write here that AP equals to 10, and from this equation 10 equals to AP equals to MB, we will derive that MB also equals to 10 units in itself. MB equals to 10 units in itself. Okay. In the next step, we know that chord PM passes through point O, and that is the center of this circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, PM is the diameter of this circle. So I copy this semicircle with diameter PM. And we analyze this semicircle with the diameter PM. So actually, this is the semicircle with the diameter of PM, and we know that PQ equals to 10 units in itself, and B equals to also to 10 units, and QB is the missing side, is equal to X. We have to find out the value of X. So in the next step, we extended side PQ and this side MB until they touch each other. This is the touching point. We define this point, the touching point is point E. By doing this construction, we can do triangle PEM. This is triangle PEM. Line segment PQ equals to line segment MB. When we extended line segment PQ and line segment MB, we created this triangle PEM. Here, line segment QE must be equal to line segment EB. So if QE is Y, therefore EB must be also equal to Y. So in total, PE is equal to 10 plus Y, and EM is also equal to 10 plus Y. Therefore, side EP equals to side EM in triangle EPM. Again, side EP equals to side EM in triangle EPM. And we also know that in front of equal sides in the triangle, there are equal angles. So in front of this side EP, we have this angle. In front of this side EM, we have this angle. And because of the fact that those two angles are located between those two equal sides, they must be also equal to each other in their sizes. So if the size of this angle is beta, then the size of this angle must be also equal to beta according to the rule that I mentioned. So we have this is quadrilateral QBMC, QBMP. This quadrilateral QBMP is inscribed, if we complete this quarter circle by a circle, it will be inscribed by a circle. So quadrilateral QBMP is inscribed by a circle, and we know that any quadrilateral that is described by a circle, the sum of its two opposite angles must be equal to 180 degrees. So the quadrilateral QBMP, those are the two opposite angles. So according to the rule that I mentioned, the sum of those two angles must be equal to 180 degrees. But this is angle beta. So angle beta plus the size of this missing angle, in total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 180 degrees minus beta. Why? Because 180 degrees minus beta plus beta is 180 degrees. That is the sum of the opposite angles in a quadrilateral that is described by a circle. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. Therefore, but this is angle beta, so this missing angle must be equal to 180 degrees minus beta, right? Because 180 degrees minus beta plus beta is 180 degrees. That is the sum of two opposite angles in a quadrilateral that is described by a circle. So in total, we have found out that those two angles, this angle equals to 180 degrees minus beta, and this angle equals to beta. So the sum of those two angles is 180 degrees. Why? Because 180 degrees minus beta plus beta is 180 degrees. But those two angles are defined as one-sided interior angles. So we have found out that the sum of those two one-sided interior angles is equal to 180 degrees. Therefore, according to rule 18, if the sum of two one-sided interior angles is equal to 180 degrees, then they must be located between straight lines. That is to say, and those two one-sided interior angles are located between the straight line QB and PM, and therefore QB must be parallel to PM. So repeat quickly rule 18. According to rule 18, if the sum of two one-sided interior angles is equal to 180 degrees, then they're located on they're located between two parallel lines. So in the domain we have line A and line B. This is the line C that intersects with those two lines A and B at those 2 points. Those are two angles alpha and beta that are defined as one-sided interior angles. And we know that the sum of those two angles alpha and beta is equal to 180 degrees. And because of the fact that the sum of those two one-sided interior angles is equal to 180 degrees, they must be located between straight lines. That is to say, line A is parallel to line B. So we can implement rule 18 in our drawing, because in our drawing, the sum of those two one-sided interior angles is equal to 180 degrees. And therefore, according to rule 18, they must be located between two parallel lines. They are located between lines QB and PM. Therefore, line QB must be parallel to line PM. Again, line QB must be parallel to line PM according to rule 18. So, in the next step, I copy again this semicircle with diameter PM, and we continue to analyze this semicircle with diameter PM. So actually, this is the semicircle with diameter PM. Point O is the center of the circle. We join points O and Q together by straight line. OQ is the radius of this circle, that is 15. OP is also the radius of this 15. OM is also 15. We join points O and B together by straight line. OB is also the radius of this circle, that is equal to 15. QB is the missing line segment, that is equal to X. X is the line segment that we are looking for in this question. Okay, so here we have already found out, according to rule 18, QB is parallel to PM. Again, QB is parallel to PM according to rule 18. And because of the fact that those two angles are defined as alternating angles, again, those two angles, angle P, O, and Q, and angle O, Q, and B, those two angles are defined as alternating angles, and they are located between the parallel lines QB and PM, and therefore they must be equal to each other according to rule 15. So repeat again on rule 15. alternating angles between parallel lines are equal to each other. So in the drawing we have line A that is parallel to line B, and those two angles, alpha and beta, they are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, angle alpha equals to angle beta. So can actually implement rule 15 in our drawing. Why? Because in our drawing we have those two angles that are located between the parallel lines QB and PM, and therefore they must be equal to each other in their sizes. So if the size of this angle is alpha, then the size of this angle must be also equal to alpha according to rule 15. In the next step, I copied the green triangle PQO, and in Olympiad, actually we implemented the law of cosines, so I'll repeat quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. The law for side AB is A units, side AC equals to B units in its length, side BC equals to C units in its length. This is angle theta. So this triangle ABC that could be any triangle. Cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, in this triangle ABC that could be any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So if we implemented the law of cosines in this green triangle PQO. So I copied this green triangle PQO in the new page and implemented the law of cosines in this green triangle PQO. So actually, this is the green triangle PQO that I copied from the original drawing. In this one, this triangle PQO, this is angle alpha. So coming to the law of cosines, this triangle PQO, cosine alpha equals to 15 square plus 15 square minus 10 square over 2 times 15 times 15. Again, according to the law of cosines, this triangle PQO, cosine alpha equals to 15 square plus 15 square minus 10 square over 2 times 15 times 15. In the next step, I copied this triangle triangle QOB in a new page, and we implemented the law of cosines in this triangle QBO. Okay, so actually this is triangle QBO that I copied from the original drawing, from this drawing, from this semicircle. This is triangle QOB, and this is the angle alpha. According to the law of cosines, in this triangle OQB, cosine alpha equals to 15 square plus x square minus 15 square over 2 times 15 times x. Again, according to the law of cosines, in this triangle QOB, cosine alpha equals to 15 square plus x square minus 15 square over 2 times 15 times x. Okay, so we have two different expressions for cosine alpha. Therefore, we get an equation 3 that says that cosine alpha according to equation 1 must be equal to cosine alpha according to equation 2. Cosine alpha according to equation 1 equals to 15 square plus 15 square minus 10 square over 2 times 15 times 15. And it must be equal to cosine alpha according to equation 2. Cosine alpha according to equation 2 equals to 15 square plus x square minus 15 square over 2 times 15 times x. So, in the denominator of this side of the equation we have 2 times 15, and we have the same expression in the denominator of this side. So we cancel 2 times 15. We have here 15 square minus 15 square, that is 0. So those two expressions will get cancelled. And we left, in this side of the equation, we left only with x squared over x, that is x of course, On the other side of the equation, we left with 15 square plus 15 square minus 10 over 15. 15 is the only number that's left in the denominator here. So in total, we found out that x equals to 15 square plus 15 square minus 10 square over 15. 15 square is 225, so 225 plus 225 is 450, minus 10 squared, that is 100. So in total, in the denominator of this expression, we have 450 over 100 divided by 15 equals to x. 450 minus 100, 450 minus 100 is 350. So we have this expression in total equals to 450 over 15, that is equals to x. Here we divided both the numerator and the denominator of this number by 15, and found out that 300 by 5. We divided both the numerator and the denominator of this number by 5, and actually found out that 350 over 5 is 70, and 15 over 5 is 3. So in total we found out that x equals to 70 over 3 units. In terms of numbers, x equals to 23 and 3 units. So again, we found out that the length of this line segment PA, line segment QB is equals to x, is equal to either 70 or 3 units. In terms of numbers, the length of this line segment QB is equal to x, it is equal to 23 and 3 units. Okay, thank you very much.